gamma mu L infinity such that the integration over the cross group is 0, because this n is so the L to the n is the conductor of chi. All the time this condition is imposed. And so this is, I embedded this inside Gn to the d, maybe QL bar. And how from, if this guy is big, I have a trouble, right? So how this guy can be related to the sequence and underlined I introduced last time. And then, of course, out of that, I create this set of points in VQ, right? And so if this guy contains an arithmetic progression, then you get a Zariski density inside now VQ of this kind of point, Zariski density of psi in this. And from that, I would say that this guy is rather, that would imply f is 0 essentially. And therefore, if f is non-zero, this guy is small. That's how things go. Okay, that's what I like to do. So one thing I would do is that now I choose Q so that it is isomorphic to delta minus by projection. You see, I have CL minus infinity, you have a projection to delta minus, and the inside I have this set Q, and that is isomorphic. So the representative set I choose this way. And under some hypothesis that there's no ambiguous class and so on, then this is independent. Modulo algebraic ideas once projected to gamma. That's how things goes. So then what I do is I have a measure d phi f. This is supported on CL minus n. So by this decomposition, that of course induces each step gamma n times delta minus this part isomorphic, this part, this is not isomorphic, I mean projection. This is a finite group, and this part algebraic if n is sufficiently large. Essentially, this could show up having some trouble when n is 1 or 2, but after that, it's all the time survives. This is a profinite group.
So it's not a Hermitian. D phi f is not a
d phi f is a measure whose this is just a, this is a finite group, and each point has a volume which is the f of this. Each point has volume given by f. Okay, and now I project this measure to gamma n, just sort of weighted average by, you see, this this psi is fixed. This is the branch character, and the weighting average by over the Toujong element I just projected down. And this I write d phi f psi, and this also I put q here. All right. In other words, this is something like modular form terms. This is a summation over q, and lambda psi inverse q. Lambda has to show up when I define this value fa. We will see, but this is essentially lambda a choosing Hecke character, and then fxa, something like that. So if I just write this here, f, I write q. This part I need to add because that's q, because this is just a value of a. So only lambda inverse show up, but I need to also divide by lambda, so I need to compensate. I put lambda there, okay? And what is q? Q is the actually automorphism of similar variety, and it brings xa to xa q inverse, and this actually this is a similar variety has GL2 action, and it is basically if we choose q, well, say if q in q is actually you impose that is split prime over f split prime. That you can also all the time do by Chebotarev, because I suppose that no ambiguous classes. So if you make this kind of choice, then this is just coming from matrix the q. So maybe small q. So split means this is the f prime, o prime, and that is big Q and big Q complex conjugation, right? So I choose the prime element at lowercase q and inverse 0, 0, 1, the action, something like that, actually. So therefore, this operation, this is only defined for CM point, but it is extended to all S by this action, and it induces this kind of action. Okay, so this is averaging. I put the Q is actually, I'm putting A times Q inverse by this. So this is exactly averaging because I haven't moved by Q projection to gamma, okay? Q inverse Q projection gamma is a delta minus element. I actually then further move by this transcendental guy is putting inside there. So it's somehow also dependent on the choice of Q and so on. So I put this symbol Q there. But in writing, I might forget often. There's so many suffix and superscripts and subscripts like that. Okay, so perhaps I have said, but gamma n, and gamma n is by logarithm isomorphic to O over L to the n, non-canonically. And you take L to the j Toujong guy. So this bracket means L to the j Toujong. Then this is isomorphic to O over L to the j, but I just like to make it local. So O, L completed, L to the J or L, something like that. And this can be make it canonical so that you pick U. And actually, I pick its representative set in OL. And then I apply unipotent element, the J of U, to XR. And then you get the element exactly here. So this is somehow, so this is, alpha something is 101 star. And this is concentrated at L. Okay? So this is actually written, therefore, X of some AU. And this is just a linear algebra computation of the basis of that. So I don't really explain that, but it's quite easy. That means evaluating F at, say, XAU is basically F applied this alpha U over I L to the J, and then evaluating at A, Rn, right? So this is an algebraic operation. This is also automorphism of similar variety. Only transcendental things comes from this guy. So whatever I will make a lot of operations, as I imagined, I killed many people, so I can do something rather technical to kill further other people. Right? So I just applied this kind of this operator and that operator like this. And so the point here is that you pick chi such that conductor of, oh, I can't write this, conductor of chi is L to the N. So the symbol chi is all the time character of gamma, okay? And the psi is fixed. And n is sufficiently large, bigger than j. J is bigger than or equal to r. You remember that f p to the r is field of rationality of lambda. It's originally main point is to relate this kind of results to L values. If I forget about the L values, you can just take some modular form really defined over F, the finite field. But then you don't have really complex L function. So I usually start from some F defined over valuation ring, and I reduce modulo maximal ideal, then you get F defined over S, right? So this usually means where the modular form is defined. So lambda also, I start from something in characteristic 0, and then reduce it to modulo F, modulo maximal ideal, and I have a psi. This is also, I can start from Tahimural lift of mod P character and then again reduce back, you can do. And I have F there, F. And I further add 1 roots of else roots of unity. So I just all the time assume it by sort of technical reason. And okay.
You seem to be saying that you can capture the action by the unipotent and also by the diagonal. So what is left to capture the GL2 action would be the kind of while group element, 0, 1, 0.
While group element.
Yeah, right.
While group element brings F if it is a Hecke eigenform, then it's a counterpart of functional equation.
Yes, okay. And that is the transcendental aspect which is being captured with the.
No. This guy is not at all algebraic, so it won't extend to the automorphism of similar variety. So that's the key point, because this is a transcendental, you move around, then I can have SH to the rather big product of similar variety. You get a dense subset. See, if it is one, it's still, I can consider this psi, but it's further diagonally strangely embedded. And it's getting further and further thin. If this Q has a million elements, then it's a million similar variety, but size of psi never changes. And still it is, Zariski dense is a very strong result. So it's not something like Andre Oort or Chai's stuff, actually. Okay, so this is something Fp to the R. And at the end, I started from F. I defined F psi. Then I further make it Fv for V in the class of O over L to the J. The point here is that you have your character, chi. You restrict it to the gamma of N of L to the J. Okay? But this is, I canonically identified it O over L to the J, here by unipotent element, concentrated at L. This action is concentrated at Q. Q is outside there, they commute. And so this you can write, you have a plug in AU, then for the L to the Jth roots of unity of trace of UV, you can write for some unique V, unique V here, right? That means the integration restricted this part is related to this form Fv, which is something like U modulo L to the J of the zeta J is generator of mu L to the J. Okay? Or actually, I choose the L1 Tate twist and generator, say, one generator, Z infinity, and you project down to zeta J in mu L to the J. And in this way, I can make it compatibly, I choose for any kind of J. Right? Then zeta J of trace du of F psi, you apply this alpha U over pi L to the J, something like that you do. This is a partial Fourier, this is a Fourier transform over O over L to the J. Therefore, it's the A psi Fv is, I just put any F is okay, so I don't need to psi there, but I will apply it to psi. But anyway, this is just the size of this group, A psi F, if psi is in the my class of minus V. So if this guy is non-zero modulo maximal ideal, or in F, boldface F, then this guy will be non-zero. And this cusp form has only coefficients for psi in the class of minus V. This is just a averaging over by applying the Fourier transform thing. Then only V minus V things survive. All right, this is the kind of scheme. So in other words, I can change this Z to slightly smaller ZB such that Z is originally given here, that those integral 0, I covered all chi, but I can just assume that chi such that integral gamma n chi d phi f psi n q 0. And so this V for given chi, I have that V, right? So this V, I just write V of chi. On the other hand, if I fix that V and run all V chi is given V, then this Z is just a disjoint union of ZVs, V mod L to the J, right? I'm just split it into pieces. But if this is big, then one of them should be therefore big, right? And I just concentrate on this ZV. Then my form is just corresponding to this one, essentially. All right. So I just say something about the geometric modular form. The definition of modular form, of course, you can say that it is a function of product of upper half complex plane and so on. But that only works for Archimedean over complex numbers. And I really need some definition, right definition over the finite field or the algebraic closure of finite field. And that definition is supplied by the Deligne-Levitt. It's totally algebraic and cats or GL2. I generalize this kind of thing, so all reductive group which produces similar variety of PL type. But originally this started by these three people. And so actually, modular form is not a modular function. It's not a function over the similar variety, but it's a section of line bounding. That just means that modular form is a function which assigns the rule to the Hilbert modular William variety and the polarization, but I just forget about polarization. And level structure W. And one more thing is that differential. And that is sent to, if this is defined over B, so B is either therefore W or this finite, algebraic closure of finite field, then this is defined over some A is a B algebra. So this is the variable A, and these three things are variables. And it's a function of it. And actually, it's a functorial rule. It's a categorical thing. And assign the value f of x omega. What is omega? Omega is everywhere non-vanishing differentials. In other words, it is an abelian variety. You take x and its first differentials. And this has an O multiplication. Then you have a unique generator, omega, over this ring. If it is an elliptic curve, it is just A, right? But this is a higher dimensional abelian variety with O multiplication. So these three things there, and it satisfies three axioms. G1. If you have a B algebra homomorphism. So A goes to A prime, B algebra home. Then you plug in X, W, omega. This is defined over A. And you make a base change to A with respect to phi of this A prime. Then you get a value applied phi. Okay, G2. So F is finite at cusps. So the cusp corresponding to the Tate-Abelian variety. And this Tate-Abelian variety is defined over Q expansion rings. So it has also canonical level structure and canonical differentials. And you plug in Tate-Abelian variety, plug in F, this triple or quadruple of Tate-Abelian variety. The value runs to the Q expansion ring. And that Q expansion has no Q to the negative guy there. So that is the finiteness of cusps. Right? This, I don't go into much detail. So construction of Tate-Abelian variety is, of course, due to Mumford. Tate constructed Tate curve, but number theorists tells this, call this a Tate-Abelian variety. Algebraic geometry calls it Mumford-Abelian variety, whatever. And third thing is that, so if you, there's ambiguity of omega, because this is the point that we have a section of a line bundle. So this omega, you can change it to psi times omega. The psi is a unit of this O tensor A cross, right? Then how value changes? So F X W omega psi omega, then you get psi to the minus K sigma F X W omega originally. What's psi K minus K sigma is just a product over sigma in the CM type of psi to the minus K sigma. Okay, because I tensored A over Z of O, the sigma extends to this guy into somewhere, right? So in this sense, this is a character of torus. This, you can write this GM restricted from O to Z evaluated at A. So this is actually a character of that torus.
High-dimensional number of varieties. Is it the cusp is a set of points, or is it a divisor?
Cusp is a point.
Or it's not a divisor?
No, the Hilbert modular variety has quite high singularity at the cusp. It has to be a divisor, but it's a point. And singularity is awful because Q expansion ring is something like A. So it's written by Q or something. It looks like a power series ring, but it is actually those of sigma psi in O or something like that. A psi F, Q to the psi. And this is not an integer. It's, you know, exponential 2 pi I trace of psi Z. Yeah. So this psi, you know, it's sort of product of Q sigma, psi sigma kind of things if you write in Q expansion form. And this augmentation idea is the cusp, and it is very singular. And therefore, to make it divisor, you need to make a smooth toroidal compactification. That was very hard work of Mumford and Chai and so on. And it's not something trivial. Okay. And the problem on Hilbert modular variety is that you can, of course, make a resolution of singularity by the smooth toroidal compactification, but it's not unique. And this GL2 action of Shimura GL2 action won't extend to the toroidal compactification. And that's also another real trouble. But anyway, I don't care about that for that kind of things. Okay, but however, I should say that, over Q, if you have a Q expansion, you have this kind of operator, say D. So that means A and F goes to N times A and F. Ramanujan's differential operator. And in Hilbert modular case, you have a dq as I wrote, sigma over q d, q sigma things and the product, and you raise the power kappa sigma or something. Then this goes a psi f goes to psi to the kappa in that kind of sense, a psi f. And miraculously, this is algebraic operation, periodic modular form applied. This is the periodic modular form again. So mod F modular form applied. This guy is the mod P modular form again. Of course, Ramanujan never know that, but he somehow, in some sense, he knew that this is algebraic operation. And so if you change F to this kind of things, F, then it's still a periodic modular form. My argument works. However, you evaluate something, you plug in abelian variety XA or something like that, right? Then in the complex side, Archimedean part, it is not really there, this operation. Then you need to apply this Shimura's differential operator of Shimura mass. And this is a C infinity modular form analytic, but not holomorphic. But still, of course, you can plug in A. And again, miraculously, the value of this guy A divided by some periodic period is the corresponding Archimedean period is there, and this is equal. This is cat. And this is Shimura's operator. So all the arguments actually work, but this involves a lot of work anyway. And I rather like to forget about it. So I assume that kappa is 0. So the evaluation did the L value change by twist by kappa, but this is quite of course, there's an exponent, but it's dependent on kappa. But I don't care about that. So just I wrote omega p. And this exponent things, if you want to write down, then I need to write down some formula, and that I don't like to do. Okay. And to make, so how you choose, then once you, by the way, once you do this business, psi minus k sigma, this weight k condition of this holomorphic modular form becomes psi to the minus k sigma minus kappa 1 minus complex conjugation. You see, psi is a real element, totally real. Actually, this doesn't show up. I wrote that way, but if you plug in CM point, then this really acts. So anyway, I assume kappa 0, it doesn't matter. Okay, so I now choose lambda, choice of lambda. I'm supposed to end at 1 p.m. Yeah, but this is just, I can kill your lunch. And so for simplicity, again, I assume that Neven character of F is trivial. This just means central character has conductor 1. So it can be non-trivial, I mean the normal character to the some power. All right. Then if x you multiply psi, as I said, x psi a, say this is level n, may not be isomorphic to xan. Psi is some element now in M cross, right? Because this psi has the principal idea of Rn pick Rn, then this guy may not be trivial. Right? That kind of. Then this is equal f x psi a, then psi w multiply level structure, you have to multiply level structure xi by psi, and psi multiplies the differentials, right, to bring that, to extend it to triple. Then this guy is psi to the minus k sigma f xa original guy. Okay, so I choose lambda so that its value at psi is psi to the minus k sigma, right? And then you fix this 1 omega for this xan, then you know lambda a inverse fxa only depends on because if you multiply something, you get this amount of thing. And this guy also has this amount of things changes. And you multiply it by inverse, it kills it. Then it depends on actually the class of A in CL and minus. And also the CLN minus, actually I model out, it's a co-kernel of the pick image of class group of F. So I actually need to assume that lambda restricted to FA cross, the Hilbert modular, is the central character of F. Then this is originally no minus. Then by this fact, I can put minus there. So this, I write this to be F class. And this is the volume of the measure at point A. Francesco's writing so beautiful. And his lecture so well organized. That's all the time the case. I know him while he was a graduate student, and it was like that. The only guy who could do is like that is Andrew Wiles. And my writing is so bad. Hardly Japanese. Okay, anyway, I can basically have FA or FBA or F psi A whatsoever kind of things. So I want to now claim that integration of gamma n is pi, and d phi q f n or something, and you want to make conjugate. Sigma is basically Galois group of f over f p to the r. This is a field of rationality of f lambda psi and mu l. Okay? And I might want to have slightly more else roots of unity. Then I want to claim that this is 0 if and only if this gamma n chi d phi f and q is 0. So whatever you move around by conjugate this Frobenius, this sigma is characteristic field of Frobenius element to the some power, and the vanishing doesn't change. Then what I do is that I sum up over sigma. This actually, this sigma of course fix f lambda and so on. So this measure doesn't change. So this is actually gamma n chi composed sigma d phi f n q. So conjugated guy is 0 is equivalent to the original guy integral is 0. Then I'm allowed to sum up over sigma, trace down to your bottom field like this. Trace of roots of unity, Kaiser having various roots of unity, then it has very small range of non-vanishing. So I can ease my question quite. Okay, so what I do to prove this is I use Shimura's reciprocity law. This comes from theory of complex multiplication of Shimura, Taniyama, Andre Weil, but he used this in Shimura variety context to characterize his Shimura variety. Okay? And Dering also essentially used that stuff to characterize his Shimura variety. Shimura's Shimura variety and Dering's Shimura variety is kind of different. Though describes the same thing, formulation different. All right, so I have M sigma, CM type. Then I have its reflex. This Shimura-Taniyama-Weil thing, you see, you have a modular curve, you plug in CM point, you get a abelian extension of your imaginary quadratic field. And that theory was not, it is a Kronecker thing, middle of 19th century. And it was 100 years it took to generalize to higher dimensional abelian variety. The point here is that Shimura-Taniyama-Weil found that modular form over F, plug in CM point like this, produce abelian extension of different fields. And that's this reflex field. Okay? And the point here is that, so it is defined now over E. So E is contains imply automatically field of rationality. I don't recall the definition. That takes quite a time. So field of rationality of now F over W and lambda over W and psi over W. Okay, it's a finite extension of imply. Then the value of F at CM point of this guy produce abelian extension of CM, abelian extension of M prime. That's the solution of Shimura-Taniyama-Weil of Hilbert 12th problem. Okay? So it's a direct generalization of Kronecker thing. It doesn't use any L value kind of things like the Summit talk. But Summit talk is much more beautiful because you know how it moves. But on the other hand, this guy produces the similar variety theory, and so it's more sort of abstract. Okay, so the point here is that I have M and Q and M prime, and this both contained in Galois closure of M, by definition, actually. Then I just pick any B in MA prime cross there. Then I define, I have sigma here, sigma prime here inside M prime, inside sigma prime. And so you can apply sigma prime to this ideal. You get an ideal somewhere in between, okay? Then you make a product, B to the sigma prime. So it's a product of a sigma prime in sigma prime of B sigma prime. Then this runs in MA cross. This is a CM theory of a abelian, complex multiplication theory of a abelian variety. Then what happens for F sigma? So sigma is just now, this is over W, okay? Out in symbol. So this is defined over E. E is the extension of M prime. So I need to project down. So it's B of E out in symbol. And you norm down, that is norm E to the M prime B. All right, so you move by this sigma, this out in symbol, what you get? F norm B minus sigma prime. This guy is in MA cross. Okay, so you can apply to the ideal A in M. You get this. So this is the Shimura's reciprocity rule. This tells immediately the fact I want. Yeah, this one. All right, I just erase it. Maybe I write it again here. Sigma is BE. B is I pick any. So B is EA. If you take fractional ideal, I need to fix a Lie class group and so on. So I just do it over ideal. But ideal acts on ideals. So integration gamma n chi d phi f q and so on, right? And I just apply sigma. It's just a summation, something of f a q gamma kind of things, a and q, and apply sigma, okay? Here, basically chi a, okay? Apply sigma, but this is fixed by, I took the, E is a field of rationality of F. So this sigma gets in it. So this is basically, however, here you have a multiplication by norm B minus sigma prime gets into it by Shimura's reciprocity law. Okay? You feel that this is transcendental, but it's the level n. So this guy level n is represented by ideal. So it's really ideal. It's a finite level thing. All right. So then you make so NBA kind of variable you get. Then you make a variable change to A. Then it's you get AQ here, but chi sigma norm B sigma prime A and F original A and Q gamma kind of things. That means this is a character, this value gets out. So it is chi sigma norm B sigma prime and the integration of chi sigma d phi f cube psi and so on, right? So if this guy inside is 0, then this non-zero number times this guy. So therefore, things I claimed here is given. So catch is just you conjugate character. Your integral vanish, conjugate guy vanish. Okay, so I go on here. So you say, so I now take trace of Fp to the R of the field generated by F by the value of chi and Fp to the R of some mu L to the J. I just fix J bigger than R, and that is bigger than 1 because I plugged in it's a field of rationality of mu L already there. That I write trace. So suppose the inside guy vanish, then this chi sigma things vanish. I sum up over sigma over the Galois group of this character. So the sigma is now Galois group of F over Fp to the R mu Lj or something like that. I can plug in here for this field. That's the field of rationality for all everything that appears. So that means if you assume vanishing of one guy, then I sum up, then it's still vanishing you get. All right. So suppose vanishing of this guy. Integration gamma n chi d phi f q and so on vanishes. This is a hypothesis. Then I sum up, apply trace. Then it's still 0. Trace of chi a lambda psi inverse q. This junk, you can forget about that, but f applied q. And I can plug in a, but I just multiply one more ideal. I mean, any ideal, it's true. And then I apply transcendental guy. Okay, this guy doesn't, sigma doesn't affect this guy, but this, you get trace. You know, trace is kind of funny. This is the idea of Somnath, but when he proved the this kind of result for Dirichlet values, reproving the Ferrero-Washington thing, and not Ferrero-Washington, Washington, I think, and Somnath's proof beautiful. I don't like Washington's proof, but that is generalized. I'm not saying it in effective. It is generalized for Butler Cornu, quite general case. And I love the Somnath. I tried that for using algebraic geometry, not ergodic theory. All right, one thing is that trace, you apply, say, chi A, right? This is just if chi-a is index shows up, times chi-a, if chi-a is in the bottom field. This is stupid, but ULJ. But if not, it's just 0. Chi-a is outside. Its order is bigger than L to the j. You apply roots of unity, L's power roots of unity, and that L's power is bigger than, say, equal to 2. You project down to, say, at positive power of Lj, the primitive root has a 0 trace. Everybody knows, right? And this sum, this trace guy actually becomes, now this A runs all gamma n, but those Q, those A, whose value of chi having values in mu to the L to the j, order j guys, it's order L to the j guys is just concentrate, right? So it is just, of course, the index show up. That is Ln minus j, actually. This is index. Index appearing here. It's L power roots of unity, L power. Index exact number doesn't matter because it's non-zero. But anyway, showing up. And then Q is just running gamma n of L to the j tilde guy. It gets far smaller than zeta to the j trace. Chi, this is the value of chi a. That is intact, trace of uv. Chi from this plus of v. And sigma u mod lj of junk factor there, f applied q, then applied alpha u over pi l to the j, and the surviving guy is just class of v. This guy becomes au, and this covered by this guy. So this is just FV, I forgot, gamma, oh no, Q, gamma transcendental guy, FV of B, Q, gamma, and lambda psi inverse Q, summation U, L to the n minus j, and that's equal like that. And things get very simplified to LV thing. And the summation is just a modulo L to the j. No, I'm sorry, summation over Q. Okay, so this is a reduction process. So I almost run out of time, I think 5 minutes. And I don't take your lunch out. Conclusion. Oh, by the way, this kind of lecture note is posted on my web and also ICTS web. On my web is faster. This lecture 3 note is also posted. And preliminary version of the paper is also posted on all this kind of things. Those surviving guys may have some good interest in it. Okay, so I just to the conclusion. So I just put F tilde to be the sum over Q of one tensor, tensor 1, tensor lambda psi inverse q of fv at q slot, tensor 1, tensor 1. This is a modular form on v to the q, right? So this is then what you get, this L to the n minus j and so on. But this is just a value of this f tilde evaluated at s of b, right? So by this computation, if I suppose this is 0, then this guy will be 0. Okay, for B in gamma n. So from this, so it's a kind of punchline. Punchline is that I just define an underline to the those n such that conductor of chi is L to the n and integration gamma n chi d phi f psi q is 0 and v chi is given v. Okay. So if then this of course produces psi and bar. Well, any j is okay, but later I need to choose j sufficiently large to prove Zariski density. If this guy is psi, so if this nj contains arithmetic progression, then this guy is Zariski dense in v to the q, and this fv value at this point in psi vanishes entirely. So by Zariski density, fv over f will be 0. But I assumed that in non-vanishing theorem, xi(f) is not 0 if psi, actually in non-vanishing theorem, any class, I have something like that dependent on v, but at least it is in minus v, it is non-zero. But this is equivalent, as I explained, xi fv is non-zero, right? And therefore, fv is non-zero by Q expansion principle, and it's a contradiction. And that's how non-vanishing theorem tells you. So I have run out of time a bit. Like Francesco said, I will be over a few minutes. Actually, he is over 7 minutes, and it's not a few minutes, I think. But anyway, I use a rigidity theorem. Rigidity of torus. So I have Z M D Q L bar. And I have some subset, say ZB. And this contains for Frobenius, this sigma this sigma I had is just a Frobenius to the some big P power. K is no good. J, I sufficiently large, right? Okay, so this, and you apply sigma, the vanishing doesn't change, so it is stable under the Frobenius. This is a character, so I can just raise the power to the P. This kind of subset is called rigid subset of GM. And the point here is that Zariski closure of rigid subset is essentially subtorus, not equal. I mean, if it is really Z or Z is defined something to be, I erased. Z is a zeroth Z. In other words, Z is basically chi with integral gamma and chi d phi is 0, and v chi is given v, something like that. I can also consider the same sort of things of opposite non-zero, v chi is v. This is also stable under the raising the power p, right? Therefore, actually what I apply is that it is x I apply. So if it is Zariski closure is really smaller than gm to the d, then this subtorus is really smaller than gd to the gm to the d. It's something like picture is that say d is 2, the only this line carries non-vanishing thing. That means I have a lot of vanishing guy. And I can easily show and underline. So vanishing this sequence contains arithmetic progression. And that's how things goes. So I will explain this rigidity theorem in a regular sum next time and prove the non-vanishing theorem. I think I can finish fairly early next time. I just compensate today's few minutes. Okay, thank you.